Alright, here we are going to solve a linear system using the substitution method. First thing you want to do when looking at solving systems using substitution is you want to identify which variable in equation 1 or equation 2, the top or the bottom, might be best to solve for. Our whole goal here is to be able to, we're going to use this red box as we talked about in class. We're going to see what can we solve for to make sure that we can substitute that in for the variable. If we look here, the first thing I notice is that I have 3x plus y. Well, the y is all by itself. There are no coefficients. The coefficient is the number in front of the x, the number in front of the x and y here. So 3, -2, 4, and technically there is a 1 here, but we're happy with 1s. So we have y all by itself. That indicates that this is the equation that we want to take, and we're going to rewrite that equation just right over here. So we get 3x plus y is equal to -7. And our goal here is we need to solve this equation for y. Just like we did when we were graphing, we're going to take and tee it up, and then we're going to go ahead and we need to move this 3x over to the other side. Well, we can't just move it, we have to have a reason for it. You need to have that reduced down to 0. So it's a positive 3x, so we're going to subtract 3x to both sides. When we subtract 3x to both sides, the 3x will cancel out over here. So 3x cancel out, and we end up with y equaling, now here again we have different terms. We cannot add these since I like to put the x first. So we have -3x plus -7. Alright, so we have our equation solved for one variable. In this case it happens to be y. We're going to go ahead and we're going to take this box. Now we're going to take the box and circle or box whatever y is equal to. In this case, y is equal to -3x plus -7. I'm going to get rid of this line here just so it appears better. Now, here's where we take the second equation and we're going to use the actual substitution method, where you are going to substitute in any spot you see a y, we're going to replace it with -3x plus -7. So we're going to take this equation here and we're going to rewrite it exactly as it is, except for the y, we're going to put -3x plus 7. So here's the substitution. 2x plus 4 times y. However, instead of y, we're going to replace y with -3x plus -7. And that still is equal to 0. So notice we didn't change anything about that second equation except for we did the substitution of y. Now, this is an algebra problem. Our goal is to then tee it up, and we need to follow all the correct algebra terms to solving for x. Notice x is the only variable that's left over. First thing we're going to do is we're going to distribute. 4 is outside of the parentheses. So we're going to distribute that 4 to everything inside the parentheses. Remember, distributed property. This 2x is just sitting outside. We haven't done anything with that yet. So if you look, 4 times -3x is -12x. 4 times -7 is a -28. and that is still equal to 0. After the distributive property, I notice that we have negative 2x plus negative 12x over on the same side of the equal sign. These are like terms. We're going to add those like terms together. When you add two negatives, you get a negative. In this case, it's negative 14x plus negative 28. And that's equal to 0. So now we're looking at a two-step algebra problem. When solving two-step algebra problems, you want to deal with the constant term first. We need to move this 28 over to the other side. So we're going to go ahead. It's a negative 28. So if I add 28 to both sides, the 28s are going to reduce down to 0. They cancel out. And what's left over is the negative 14x. 0 plus 28 over on the right side gives me a positive 28. And now I'm left with a one-step algebra problem. Well, negative 14 times x, remember when it's together that is multiplication. We need to divide both sides by negative 14. And when we divide by negative 14 to both sides, this leaves us with x by itself. 28 divided by negative 14 is negative 2. And notice, x is by itself. We just solved for x. We have half of our solution. The next thing that we want to do is we want to go ahead and take this x, and we're going to bring it right back to the boxed equation. That's the reason why we box it. If you notice, y is already by itself over here. So if I know x, I can substitute in, and we can find y pretty easily. So take the negative 3x, but instead of x, we know that x is negative 2. So I'm going to replace x with negative 2, and then we still have the plus negative 7. So, solving, we've got y equals negative 3 times negative 2 is a positive 6, plus negative 7 drops down. Now we just are going to add 6 plus negative 7 is negative 1. And we found y. Notice we have x by itself and we have y. To finish, we have our solution. The solution, x comes first, is negative 2, then y, negative 1. And I always sneak x and y right underneath because I know in any ordered pair, x comes first and then y. And that is the solution to the linear system. What would be a wonderful idea now is to go back to the original equations and plug in negative 2 and negative 1. And then we could check and see, do the equations, in fact, balance out? And I think I'm going to do that here. I'm going to erase just this portion. And we'll go to a new slide. So I'm going to copy this. And I remember my solution is negative 2, negative 1. So let's go ahead and check that. Here's my original equation. My solution is negative 2, negative 1. And we're going to go ahead and just plug that in to check. X is equal to negative 2. Y is negative 1. Let's take the very top equation. And let's just replace x and y. So I just put in 3 times x, well, x is negative 2, plus y, y is negative 1. And if everything turns out, we want that to equal whatever is on the right side. So, solving, let's simplify. 3 times negative 2 is negative 6, plus negative 1. Simplifying that a little more, a negative plus a negative continues to be a negative. So we have negative 7 equals negative 7 over here. This is a true expression. Since this is a true expression, that means that when we plugged in the solution, negative 2, negative 1, that is a solution for this line. Now, we have to check the other solution, or the other equation. So we'll take this other equation, and we're going to still use the same x and y and plug that in. So now we have negative 2. Right here's negative 2x. Well, x is negative 2. So we're going to substitute that in. Plus 4y. 4y is negative 1. And if we simplify that, it should equal 0. So let's see. Negative 2 times negative 2. We'll multiply those to get 4. 4 times negative 1 is negative 4. And positive 4 plus negative 4 is 0. Well, 0 equals 0. Another true expression. Since that is a true expression, that means that our solution to the linear system is true. Negative 2, negative 1.